Have you ever wondered what the world will look like in just a couple of years? Forget flying cars for a moment and think about the invisible revolution happening right now. I'm talking about quantum computing! And by 2026, it's set to change everything we thought we knew about technology. So, grab a seat, because today we're going beyond the hype to see what's really coming. First, let's get one thing straight. Quantum computers aren't just super fast versions of the laptop on your desk. They're a completely different beast. Your current computer uses bits, which are like tiny light switches, either a 0 or a 1. Simple, right? Quantum computers use qubits. Now, imagine that light switch could be on, off, and somehow both at the same time. That's a qubit, thanks to a mind-bending principle called superposition. And it doesn't stop there. Qubits can also be linked together in a spooky way called entanglement. Albert Einstein famously called it spooky action at a distance. This means if you measure one entangled qubit, you instantly know the state of its partner, no matter how far apart they are. It's this combination of superposition and entanglement that gives quantum computers their incredible power. They don't just solve problems one step at a time. They explore countless possibilities all at once. So, why does this matter for 2026? Well, for years, quantum computing has felt like science fiction. We had small, unstable machines that were more like lab experiments than actual computers. They were noisy, prone to errors, and required extreme conditions, like temperatures colder than deep space, just to function. But that's all changing, and fast. The big story for 2026 is the dawn of what experts are calling utility-scale quantum computing. This doesn't mean we'll all have quantum mech. It means we have machines powerful enough to solve problems that are impossible for even the world is best supercomputers today. We're talking about systems with hundreds, maybe even 1,000, stable and interconnected qubits. This is the turning point, the moment quantum computing steps out of the research lab and into practical application. Let's talk about what this actually means for you. One of the most exciting areas is medicine and materials science. Imagine trying to design a new life-saving drug. The human body is incredibly complex, and simulating how a single molecule will interact with it is a monumental task for classical computers. They have to approximate and simplify. But a quantum computer can simulate that molecule with perfect accuracy, because at its core, nature itself is quantum. By 2026, researchers will be using these machines to design new drugs faster than ever before. We could see breakthroughs in treatments for diseases like Alzheimer's or cancer. Similarly, they could help us invent new materials. Think about creating a new type of battery that's incredibly efficient, or a new catalyst that pulls carbon dioxide right out of the atmosphere to fight climate change. These aren't just dreams. They are problems that utility-scale quantum computers are perfectly suited to tackle. Next up, finance. The global financial market is a chaotic system of trillions of data points changing every millisecond. Predicting market trends or calculating risk is a high-stakes game of probability. Quantum algorithms are brilliant at optimization problems, which is exactly what this is. By 2026, we expect to see financial institutions using quantum computers to build far more accurate models for risk assessment and investment strategies. This could lead to a more stable global economy, or it could give a massive edge to whoever gets there first. It's a race, and the finish line is getting very close. Think about a company like Amazon or FedEx. Figuring out the most efficient route for thousands of delivery trucks is a legendary computational problem. A quantum computer could solve it in a fraction of the time, saving massive amounts of fuel, reducing delivery times, and cutting down on emissions. Of course, with great power comes great responsibility and also great risks. The elephant in the room is cryptography. The security that protects your bank account, your private messages, and government secrets relies on mathematical problems that are too hard for classical computers to solve. For a powerful quantum computer, however, many of these problems are trivial. This has created a sense of urgency. The good news is that experts are already on it. By 2026, we'll see a massive push towards quantum-resistant or post-quantum cryptography. This involves developing new encryption methods that are secure against both classical and quantum computers. It's a critical upgrade for our entire digital infrastructure. A global security patch that has to be rolled out before quantum computers become powerful enough to pose a real threat. So, who are the key players in this quantum race? It's not just a handful of university labs anymore. Tech giants like Google, IBM, and Microsoft are pouring billions of dollars into their quantum hardware divisions. Google's Sycamore processor famously achieved quantum supremacy a few years ago, performing a calculation that would take a classical supercomputer thousands of years. IBM has a public roadmap to a 1,000-qubit machine and is already letting people access their smaller quantum computers through the cloud. Then you have a whole ecosystem of specialized startups, like IonQ and Rigetti, who are pioneering different approaches to building qubits, using things like trapped ions or silicon. Each approach has its own strengths and weaknesses, and by 2026, we'll have a much clearer picture of which technologies will dominate the future. It's not just companies either. Governments around the world see quantum computing as a strategic priority, funding research and development to secure a national advantage. Now, let's manage expectations a little. Will quantum computers replace our phones and laptops by 2026? Absolutely not. For everyday tasks like sending emails, browsing the web, or watching videos like this one, your classical computer is and will remain far more efficient. Quantum computers are specialized tools for specialized problems. Think of it like this. You have a car for driving around town, but if you need to lift a 10-ton block of concrete, you need a crane. Quantum computers are the cranes of the computational world. By 2026, we'll likely access their power through the cloud. This hybrid model, where classical and quantum computers work together, is the most likely path forward. So, 2026 is shaping up to be a landmark year. It's the moment the quantum promise begins to pay off. We'll see the first wave of real-world applications in drug discovery, finance, and materials science. We'll be in the middle of a global transition to quantum-resistant security, and the competition between tech giants and nations will be hotter than ever. It's the end of the beginning for quantum computing. The theoretical groundwork has been laid, the experimental machines have been built, and now we're ready to unleash their power on problems that truly matter. It's an incredibly exciting time, and we're all going to have a front row seat to watch this revolution unfold. Thanks for joining me on this journey into the near future. If you're as fascinated by this stuff as I am, make sure to hit that subscribe button and ring the bell so you don't miss our next deep dive into the tech that's shaping our world. What part of the quantum revolution are you most excited about? Let me know in the comments below. See you in the next one.